Hello everyone, this is Mr. 13 Things, or Silence Did Good, coming at you in the second of a series talking about why, in fact, the name of the website and the concept is We40Kids, which tells us that effectively until we get our kids confident that what they're doing on their game consoles in about second or third grade or kindergarten or fifth grade, that they are capable of doing it in math, we're going to have a disconnect is my general belief. And part of my disconnect, I guess, would be I should have known right here to have put this on a separate layer, which we'll talk about later. We start talking about how to deal with matrices. So right now I'm going to go ahead and edit and cut the whole thing. Edit, cut that, and now I'm using a program called Smooth Draw. I'm using Khan Academy Yellow. People tell me there's actually got a name. That's kind of cool. Got a whole color named after you. And what I'll do with a quick review so we can kind of catch up to speed that we are talking about 3D animation, or the basic math of it, the linear algebra. Big word. Of course, people are algebra, but basically, perhaps, maybe matrices and vectors is not so scary. A vector being a subset of matrices, a vector being a single column or a single row, but we'll think about it as single columns. This is a vector. Typically, we're going to deal with x, y, z, and then 1 as the scale factor. So scale factor. So this is not time. So x, y, z, and 1, talking about 3D animation, and also getting back to the fact that where our kids are is that they know that, and this is not red, but it'll be close enough. Our kids know that x is red in their game consoles, y is green, and z is blue. And I'd be really curious to do an age survey of kids and see how many of them kind of understand those colors, even though they don't know it, because that's kind of been the accepted standard for quite a while here, at least in the gaming world. All right, so 3D animation, and we deal with that, if we remember, by dealing with, see if I can use the color suck tool. Not bad. It must average. Okay, we do that with dealing with, let me go back to yellow here. All right, so one thing I'm going to tell you we're going to want to do over time is to get a little palette over here to kind of pull from. So we're going to deal with, basically, at the starting point, the number 1, which is an identity matrix, times that vector with a chaser, x, y, z, and then 1. And this is the transformer. We apply that to that, and we get a new vector here. All right, so what we're going to now do is go back to, before we go forward into how the mathematics of this works, which is multiplying a row by a column for each time, row by column, row by column. We'll talk about getting kids desensitized to some of the numbers that are not so scary that come up when you're doing 3D animation down to, and we're going to do this down to 15 degrees. So we're going to do that down to 15 degrees, which is the same as pi over 12 radians. And you can see you don't write radians here, which is the same as about the same as 1 hour's rotation of the Earth. So hopefully you can have the kids sometime, they can measure that in any number of different ways so they get attached to the fact that this 15-degree gradation of a circle is a reasonable one to stop at. You can go smaller than that, you can go larger than that, but getting it down to there is going to make it palatable as we start dealing with some of these numbers here. What really makes it palatable is to go down to 30 degrees or 45 degrees as well, and we'll see where that comes up. So when you deal with angles, there's a couple things that come up, but basically you deal with irrational numbers. And if you want to see a really good discussion of it, go out to Professor Wilderberger's Wild on Triggs site and see how he talks about the history of it. But what we're going to need to do is we're going to need to desensitize kids in any number of different ways to the fact that when they see something that looks like a square root, right, looks like that, and we're going to write that also as a V. So square root of 2, we're going to write that as a V2 because of keyboard stuff. You know, we'd like to be able to do that, but we can't. So the square root of 2, the square root of 3, and really just those two, but we'll go all the way up to the square root of 5, and sure, why not to the square root of 6, and we'll see why later. We might have kids kind of understand graphically what these numbers are. These numbers all emerge from some of the basic Platonic solids, from these basic regular polygons, but stumbled upon it just recently. The basic spiral that begins with a 1 in this direction and a 1 in that direction, right, at a right triangle. If this is 1 and this is 1, then that distance there, I'll do each of these with a different color, I guess, which is not attached to blue. Or okay, if that is there, then this is, right, so that's the square root of 2. Okay with that? If this is 1 and this is 1, that's the square root of 2. Now I'm going to go ahead and show you the next step in that. It'll be close. Now if I add that distance, which is going to do it at 90 degrees, so that's once again 1, right? Now as I go here, that distance here is the square root of 3. A right triangle with 1 and 1 as the legs, you end up with square root of 2. You add then another leg of 1, and you end up with the square root of 3. We'll continue on, I guess, logically to the next one, and we have to do that by learning to suck color. We'll see if we can suck color. Next time we'll do a little bit better. That's close enough. All right, so now we're going to add one more time. Another 1. These are somewhat approximate, right? If that is 1 and this is 1, then this next one is how long? It doesn't show up here because it's basically the square root of 4, which is equal to 2. And so kids can check that this should be twice as long. We'll try one more. We'll do 2 more in this process. Back to yellow, because we're adding 1 each time. And you start to realize where the colored chalk that Herb Gross used, or many other teachers over time, comes in. I'll go with cyan there. So if this is the square root of 1, the square root of 2, the square root of 3, the square root of 4, the square root of 5 is that. And for one last hurrah, we'll finally end up with one more. And I need another color here. I'll go back to green, I guess. And that becomes the square root of 6. Now, how are we going to plug these in here? Well, realistically, kids aren't necessarily as facile with this concept of the square root of 2 or the square root of 3. They're at the level that we're trying to get them to kind of, I don't know, get away from their Xboxes, perhaps. So what we'll end up using is some fractional approximations for these numbers, even though most people, engineers and scientists, animators that deal with these numbers, maybe not the animators, they know the decimal equivalents. And so I'll give them to you here, and I'll just give you some discussion later about how you come upon these. Pythagoras' number is pretty well approximated as 99/70ths. Theodorus's constant is pretty well approximated as 97/56. With this one, there's a nice sequence that gets you there. This one is just brute memorization and reuse. Square root of 5 doesn't have a innate, easily gotten or fractional equivalent, but it is related to, this is related to phi, and we're going to tell you that phi is the average of 1 and the square root of 5 over 2, and phi has a pretty good approximation as 610/377. And you can finally see that this one is going to be this times that, and kids can kind of develop these and start to play with all of these numbers before you even tie them into what they're going to be done here. So you're kind of showing kids these numbers in colors and what they are, and then the other places you see them is in some shapes. If this is a square, 1, 1, that's obviously the square root of 2. As you start going up from these, I think the square root of 3 turns out to be the distance, like here is the square root of 3. So these numbers can be tied to other geometric shapes, but I think because it's something you can do in colors and you can do the spiral all the way around, that you can get these numbers attached to shapes on a square root spiral, if you would. So again, this is the square, this is 1, it's the square root of 1, that's the square root of 2, the square root of 3, the square root of 4, which is 2. Students can check that. The square root of 5 and the square root of 6. Later on, you will also see that these can have area equivalents. But starting with just the length equivalents, just so students can understand that numbers mean something, and as you start realizing what's happening when you start doing animation, you're twisting things, and when you twist things, you've got a triangle which has an opposite and an adjacent, and so students can kind of get some intuition that this is what's going on when they're just plugging numbers into their Xbox, or if you would, into their TI-83 emulator calculator, into their spreadsheet, into any number of places where we are doing matrix calculations and not telling students. So the key numbers that we are dealing with here, and the order of this can be moved around with popcorn or whatever else, is we're dealing with obviously 1, which is 1 over 1, the square root of 2 and the square root of 3. This is called Pythagoras' number, I think. And this is called Theodorus' constant. This is called the golden ratio. And basically, when Theodorus multiplies by Pythagoras, you get that number there. This number here comes up. Doesn't need to, but it comes up when it comes into the memorization of the key values for pi over 12. So nowhere near as important. It is not laid out, and I'll finish up with, again, with the We40Kids site, the concept of across the top, that if kids can understand and start to use E, I, pi, -1, 0, 1, Pythagoras' number, Theodorus' constant, the square root of 5 because it's related to phi, right? Infinity, which is 1 over 0, about. A matrix and a vector, they'll come a long way, and hence you have the relationship between We40Kids and Mr. 13 Things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Also, 13 semitones in the full scale if you count the C and the C. Do, re, mi, fa, so, except do, re. I can't sing. So these things come up. Thanks for listening.